So our next step is to come up with a way to determine if two functions are inverses of each other. So I've gone back to the example we had from the previous lecture, right? I have times and the distance traveled in that time. And then over here I have distances and the times traveled in those distances. You notice this is doing what we've come to expect from inverse functions, right? The x's became the y's and the y's became the x's. They flipped. Okay, so how can we take this idea and convert it into a method for finding the inverse of a function? Well, notice what happens here, right? If I take a time value and put it into the first function, I get a number out. And if I take that number and put it into the second function, the number I get out is the number that I started with, right? And you can check this with the other ones here, right? If you put 1 in, you get 60. Then you transfer that over to here, and if you put 60 into what we've seen to be the inverse function, you get the same number back out. Well, remember what it means to put one function into another, right? That's what we mean by function composition, right? So essentially what I'm doing here is I am composing these two functions, and when I do, the output value is the same as the input value. And that's going to be our method, right? What we're going to do is we're going to check two things. We're going to look at f composed with g, and we're going to look at g composed with f. Remember, this isn't commutative. Remember, function composition, the order matters, so we have to check both ways. And if both ways we get back x, right, we get out the number that we put in, then these two functions are inverses of each other. All right, so let's look at an example. Where I have two functions here, and I have this question: are they inverses? Well, I know what to do now, right? I'm going to evaluate g of f of x. This is g of 3x squared, which is 3x squared plus 1, which is not x. So because I didn't get there, there's no point in checking the other composition at this point. The test has already failed, and these two functions are not inverses of each other, right? All right, so we've got another example here, right? You can pause this if you like. Kind of work this out on your own, see what you come up with. Then come back and we'll do it together. All right, so I have two things to check, right? F of g and g of f. All right, f of g of x. This is f of x plus 6 over 2. That is 2 times x plus 6 over 2 minus 6. The 2's cancel here. This is x plus 6 minus 6. Hey, look at that. It's just x. Awesome. That's what we're looking for these two functions to be inverses. But now I got to do the other side, right? If I come over here, this is g of 2x minus 6. So that's 2x minus 6 plus 6 over 2. And now the 6's are going to cancel. This is 2x over 2, which again is x. Excellent. That's what I'm looking for to be able to call these functions inverses. So I would say f and g are inverses of each other. Okay, so now in the last questions, I gave you the two functions. So check it out, see what you think. Right? But where do those functions come from? Right? How can we find the inverse of a function? Well, again, what did I say over and over again in the last lecture? to go from a function to its inverse, you switch the x's and y's. That's all we're going to do here. In fact, we're going to do it very literally. All right, so let's look at an example. I have this function here, 5x minus 2. F of x equals 5x minus 2. And I want to find its inverse. Well, first, in this case, I'm going to go back and write that with a y. Y equals 5x minus 2. And I want to find the inverse. So I'm going to do exactly what I just said. I am going to switch the x's and the y's and make this x equals 5y minus 2. Now, technically, that's the inverse function right there, but of course, you'd never write it like this. We're going to solve this for y first. So we're going to add 2. 5y equals x plus 2. Y equals x plus 2 over 5. Now, please don't stop there, because this actually got a little weird. I was using y up here to represent the original function, and then y again down here to represent the inverse. So yeah, that was a little strange. But so just to clarify this at the end, go ahead and write this with the function notation. F inverse of x equals x plus 2 over 5. And there's our answer. That's what we were asked to find. All right, so I've got a slightly more complicated one here. It may not be immediately apparent, but this function does have an inverse, right? So let's see. How are we going to do this? So I'm going to start with y equals 3x plus 1 over x plus 1. And I'm going to replace every y with an x and every x with a y. And now I have to solve this, right? Solve this for y and we're home free. So first, let's clear the fraction, multiply both sides by y plus 1. X times y plus 1 equals 3y plus 1. All right, now let's get rid of the parentheses. Xy plus x equals 3y plus 1. And now remember what we're trying to do. We're solving this for y. So I'm going to get all the y's together on one side. Let's subtract 3y from both sides. Xy minus 3y plus x equals 1. And everything that does not have a y needs to get out of the way. Go over to the other side. So I'm going to subtract that x. Xy minus 3y equals 1 minus x. Now we're almost there. Two more steps. Factor y out of that left-hand side. Y times x minus 3 equals 1 minus x. And now let's divide by x minus 3. And I get y equals 1 minus x over x minus 3. But again, we don't want to write it that way. Let's say f inverse of x is 1 minus x over x minus 3. And that's it. There's my inverse. Right? And of course, this is one of those things you can check your work. Rational functions, they're a little messy. But if you calculate f of f inverse of x and f inverse of f of x, simplify both of them, you should end up with x both times. All right, so what's next? We're really kind of done with the background, right? We're done with the new concepts at this point, and we're ready to move on and talk about exponential functions, which will then lead us directly into logarithms, which was really kind of our overall goal.